What's up, Algebra 1? Talking about arithmetic and geometric sequences. Wanted to demonstrate how these formulas work. The first number in the sequence is very important when you are using both of these formulas. Just wanted to highlight some things, kind of direct our attention to some different possible sequences that could be arithmetic or geometric. So let's talk about the ones on the left. 120, 140, 160, 180. If you were to subtract 140 minus 120, the second number minus the first number, you could calculate their distance or their common difference, and in this case it'd be 20. And so that value can be used in the formula, and so you can see that I have used 20 in the place of d, substituting the value of d for 20. And then you also need to understand that this notation of a sub 1 is always talking about that first number. So a is just like the notation a lot of times for sequences, and then that little subscript thing at the very bottom represents what position you are in the sequence, and if it's a 1, you are talking about the first number. So we go ahead and simplify using distribution, and then when we combine like terms, this gives us a formula that then can generate any sequence in this particular, any term in this sequence by substituting in for the position you want. So if you want to plug in 1, 20 times 1 is 20, plus 100, that gives you 120 for the first value. Or you could plug in 2. You could say I want to do 20 times 2, that'd be 40, plus 100, that would be 140, the second number. That fourth number, 20 times 4, that would be 4. Sorry, I mistyped that. I knew I did. 20 times 4 would be 80. And then let's add that 100 that's in the formula, 180. And again, that is this last value, the fourth number. So that's how the formula works, and it allows us to basically analyze some type of pattern and be able to predict what the future would be. So you could plug in 100 to find the 100th number. And that would be 20 times 100, 2,000 plus 100. I know that the 100th number in the sequence would be 2100. So that's what's great about the formula. Kind of helps you predict the future. And when you're looking at maybe this other one that's arithmetic, it's kind of more difficult, but negative 46 minus 43, you want to take that second number and subtract that first number. That gives us a common difference of negative 3. And so that would be used instead when you were to plug in to the formula. Now, a lot of people think geometric, any pattern that has more to do with multiplication or division, could be a little easier. So if you could direct your eyes to this particular formula, this is similar. It has a sub 1 that represents your first number. And the first number, I'm going to move myself out of the way. The first number is always used in the sequence, so in this case it's a 2. So if you can kind of look over here, I'm plugging a 2 in for that formula. And then you would want to use division with the second number and the first number, so 8 divided by 2. That can kind of help you understand that it's multiplying by 4 every time. 8 times 4 is 32, 32 times 4 is 128, so this is more of a pattern of multiplication, and so that 4 value would represent that R value, which is the ratio. So next we're going to do 600. That's our first number, but this one feels more like it's division, but a lot of times we're going to represent that as a fraction, and fractions are division. So you're kind of starting with 600 times 1, so you're not changing the value of 600 initially before you divide by 2. And so just make sure that you understand that you are not writing it using a divider sign, you're using a fraction. So let's look into some of the problems that we did. Write the first 5 terms of each sequence, an arithmetic sequence with a common difference of negative 0.4 and a first term of 0.7. So again, at the very top it says write the first 5 terms of each sequence. So now I want to start with what they told me at the end of that sentence, 0.07, that's my first value. And then if we go and subtract 0.4 from that, we get 0.3, continue this process to fill out the sequence to get 5 of those different values. So then it says a geometric sequence with a common ratio of 3 and a first term of 1. First term of 1, that means that first value at the very beginning value should be a 1. And then if you could just fill out those other values, we can check your work tomorrow. But geometric has more to do with multiplication, and I think I would use this. All right, the next one, number 3, it says identify each sequence as arithmetic or geometric. So then determine the common difference or common ratio for each sequence. So look at each one and determine which formula you should use, and if you can, see if you can write the formula that would match that, because that is the ultimate goal, is using these ideas of writing a general formula using substitution of the first number and either the common difference or the ratio, depending on which one you're doing. So if you can do that, that is awesome. All right, the last question real quick. It says determine the 50th term in the sequence defined by this given formula. So they haven't simplified this. They're using just that general formula we were just discussing for arithmetic. And so it's just real important to understand that the main idea is that the term value, this 50 right here, that is the input of the n, because n represents the position that you are in for the sequence. And determine the 7th term in the sequence again. So this one's more geometric. It's following that geometric model of using the first value and the common ratio value with an exponent of n. This is more linear, where n is to the first power, but in this case n is an exponent, and that changes completely how it works out when you plug values into it. So go ahead and see if you can calculate what that would be, and we'll check your work tomorrow. Have a good night.